Hey folks, my name is Rita. I'm here from Cloudflare. I lead product for our developer platform, AI. I'm excited to be joined here today by Jacob Lee from LangChain and by Philip Schmidt from Hugging Face, two of the companies doing some of the most exciting things happening in AI. And what I wanted to start with was this quick picture of the New York Times in 1996. So why am I showing this to you? I am from New York, but this is not actually about the Yankees winning the World Series. But what this is about it's about disruptive technologies. And there's this really interesting thing that happens whenever a new technology comes along. And then the very first thing that we do whenever we try to use that new technology is we bring the old technology into the new world. So what do I mean by that? Well, on this very day in 1996, this is actually what www.newyorktimes.com looked like. Now, you might note that it looks remarkably similar. And this is exactly what I mean, right? So in the old paradigm with the newspapers, right, you had to get it all ready and then get all of the copies printed out because that took some time. And then that was all you were able to distribute that day across millions of users. But the thing that's unique about the web is that you are able to generate entirely unique experiences within just a few seconds. Now, it was really, really important for companies like the New York Times, like publishers, to get started with a new paradigm, right? Just having that online presence was really, really important. But it's also interesting to reimagine what things look like when you contextualize them entirely within the new paradigm. So if you think about it in the context of what news looks like in the age of the web, it actually looks more something like this. Right? So if I'm really into AI, developer experience, programming, the weather in New York, I can get my entirely personalized news feed every single day. Now, why am I telling you all of this? Well, just like the internet, AI presents a really, really huge paradigm shift. And just like with the web, it's important to, first of all, start getting comfortable with that paradigm shift and start having a presence there. And that can be pretty intimidating. But also, I want to say that we're still so very early on in this AI space that I believe every single person in this audience has the opportunity to come up with what it looks like, what it feels like to reimagine existing experiences within this context. Now, AI is really, really fun to play around with. I just had a chance to sit down and play around with things over Thanksgiving weekend. It's my favorite time to hack around with things. And it's really cool because I have actually no artistic skills, but I was able to generate a print, right, in the style of Hokusai that represented Paris without being able to draw at all. And I think that's a really great demonstration of how powerful AI is, and of the fact that so many people dismiss it as a toy because of things like this. But whenever someone is dismissing a new technology as a toy, I think that's how you know that it's going to be really big. Importantly, though, AI is really shifting the way that productivity works and the way that communication works. And we're already starting to see early signs of that. So 55% is the time that's been saved by developers who have started using AI-based code generation tools. I want you to think really deeply about that. 55% of their time saved, right? Imagine you could save 55% of the time in your day, and you could double your entire productivity. That's a lot of time back. I struggle to get an hour back in my day, right? So if AI represents this shift that's as big as the internet, as big as mobile, as big as the cloud, one of the things that we've also seen is that with each of these paradigm shifts, technology grows and develops much, much more exponentially and quickly. And Jacob actually has a really great slide that shows just how much is happening even in like the span of the past few months in AI. So what does this mean for you? I imagine a lot of folks here, just like many of the customers that I talk to every day, have been tasked with this very nebulous thing, coming up with an AI strategy for your company, right? You have investors asking about this. All of a sudden, your CEO, your CFO, CISO, CTO, everyone is really invested in this. And some of you might have even been thinking, why is everyone asking about this now? We've been doing AI for like 10 years. We have a data science team. And on top of that, there's all of this new terminology that's cropping up that's also been really hard to keep up with, right? There's all of these new technologies and terms every day. So my hope in my talk and in our discussion with Jacob and with Philip is to help provide a bit of a framework for how to think about all of these different concepts. So this framework has really helped us and our company internally in how we think and talk about AI. And it's by splitting out, first of all, the two different types of AI. So you have predictive AI and you have generative AI. And we'll dive more deeply into each of them. But when you think predictive, I want you to think data that only your company has, right? And making sense of it in order to create either better experiences for the user or be more efficient as a business, right? So you want to predict the things that are happening next. With generative AI, on the other hand, as the name would suggest, the thing that you're doing is you're generating something entirely from scratch, and that's going to work slightly differently. Now, on the other hand, we have two very different processes that happen in AI, right? We have training and inference. And I like to also separate these out because these are going to dictate the tools that you end up using to implement each of these things. And while all of the hype, all of the excitement is happening in the generative AI space, I do think that it's really important for us to continue to think about what are the ways in which we can take advantage of technologies in the predictive AI space as well. So this gives you a slightly more holistic framework for how to conceptualize all of this. And so that's where I'm going to start. Now, I'm a PM, so it always helps me to think about things in terms of use cases, right? What are people using this for? So when it comes to predictive AI, as I mentioned, the two kind of broad categories are you have existing data, you want to make use of it in order to create better user experiences and make your business more efficient. You can see a few examples of this here, right? Things like inventory management, personalized user experiences, personalized campaign marketing. I'll even give you an example from Cloudflare. So we've actually been using AI for this use case for the past decade or so, and it's actually for the thing that you know Cloudflare best for, right? DDoS mitigation. So every day we see about 20% of the traffic that happens on the web, and we're able to take these insights and see all of the patterns that occur, right? Every single day traffic goes up because it's daytime, it wanes when it's nighttime, there's spikes when people have sales, product launches, but there are also spikes when there are attacks. And it's important to be able to distinguish these two things. And so what AI helps us to do is rather than have a person that's sitting there monitoring every single activity, we can have a machine determine these patterns and make a pretty strong prediction as to which one of these it is. So how does this all work under the hood? Well, the process generally looks something like this. The very, very first step is you want to start collecting data. So whenever users are clicking on things, if you have logs maybe from your traffic, that's a really great starting point. And you'll generally want to use something like a queuing service to then start storing all of these different events. Now, from that point, sometimes this will be done by a data science team, sometimes it's going to be done by an engineering team, but you want to start using compute to develop a model, right? And that model is going to act as that decision-making engine for you. Now, as you train this model, you're going to have more and more data that's incoming. So you might want to modify it and continue to improve it and make it smarter. And the thing here is that in predictive AI, due to the size of data generally, you do want something that's individualized to your business. And because the size of the data is, again, relatively smaller, the time to train a new model can be a few hours or days, so you can continue to iterate and verify that the new model is better than the previous version. The inference process is actually pretty straightforward, right? So something like a request comes in. So if you're doing something like tracking, what are people clicking on? Today, someone clicked on this particular thing. And the thing that you're going to do next is try to predict the next action, right? Maybe based on past traffic, if they previously clicked on this item, then they will likely be interested in this other item as well. And so you run through this model. Models in the predictive space are actually able to run on pretty commoditized compute, such as CPUs. So you don't need necessarily to invest in heavy equipment in order to be able to get started on the inference side here. Now, when you think about generative use cases, again, you're creating something that didn't exist before. So what's the most common generative use case now? it's all of these chatbots. And to me, this really speaks to the metaphor of taking a somewhat pre-existing technology and bringing it into this new paradigm, right? So we've been familiar with a search bar for the past couple decades, except now instead of typing, a pretty vague query into the search bar, we're able to give it more context and in response be able to receive something that's quite a bit richer than just a bunch of links, something that's more curated for us, something that's maybe even in a particular style, right? Maybe you want a response in the form of an essay, in bullet point form. Generative AI can do all of that for you. Very similar thing with code generation. And so a lot of these use cases, I like to think of them as how do we make humans within the company more efficient by taking tasks that would previously take humans a really long time to even get to the 90% and having AI take care of at least that very, very first step, right? So instead of writing all of the boilerplate of the code, you can have AI generate it for you so you can focus on solving the really hard problems and the algorithms and all of that. Now, the training process for generative AI is actually very, very similar to the training process for predictive AI with one key difference, which is, first of all, the size of the data sets. So I want you to when you think about generative AI, I want you to think internet scale size data sets. And as a result of that, you're going to have much, much longer training cycles when it comes to generative AI. So rather than a new model taking a few hours or a few days to develop, it's going to take months. And there's quite a few humans involved in the process as well. There's a lot of data cleanup that has to happen. There's a lot of verification. And so the way that impacts the way that generative AI works is that it's much less likely for each company to develop their own model, right? It doesn't make sense for each of us to take our cycles, right, to spend our engineering cycles on developing one of these new models. And so similarly, on the inference side, what you're going to see is process is very, very similar, but you are going to need to have specialized compute, so GPUs, in order to be able to run generative inference. And that's where, again, one of the things that we'll be talking about in our discussion is where do you go with self-hosted? When do you start to procure your own infrastructure? When do you start to go with cloud versus something like a serverless solution when you do need access to much more robust and specialized GPUs? The other thing to keep in mind with generative inference, right, I just mentioned that generative AI models are typically much more one-size-fits-all. So you might be thinking, okay, well, for my business, there's a lot of products that I have that are custom to us. Maybe there's a lot of jargon, a lot of lingo, things that are very, very specialized. How can I take this model that's been trained on all of this fast input that wasn't custom to me and use it for my own business? So once generative AI has been trained, it's really hard for it to learn new things. And a metaphor that I really like to use is actually from the movie. How many people here have seen the movie 50 First Dates? All right, quite a few folks. And if you haven't seen it, I think it's pretty common on planes, so maybe check it out on your flight back. But the idea is you have Drew Barrymore's character, right? And she keeps going on dates with Adam Sandler's character, but she's had an accident, so she can't actually form new memories, right? She has all of her past memories of her childhood and maybe what she learned in like 3rd grade biology. But when it comes to remembering what happens on their dates, every day is a hard reset. And an AI model, once it's been trained, works a little bit similarly to that. So how do you provide it with the context that it needs? So one way to do that is through a technology called a vector database. And to use the analogy here, this is a little bit similar to, in the movie, every morning when she wakes up, Drew Barrymore watches a video about everything that's happened in her life in the past few months, right, to give her that context. And so this is exactly what we're doing. We are scanning, maybe if you have a product catalog, you can have that product catalog be indexed and then saved in a vector database for the model to be able to access it whenever it needs in order to be able to answer specific questions. And so when someone comes in, maybe they're doing some Christmas shopping and they ask, what's a red shirt that you can find? It'll look for things that are similar, right? So this is kind of how the vector representation works. It's going to look for things that are numerically similar and start to pull up items that fall into that category. So that's one way of customizing outputs. Another way to customize generative AI for your particular use case is through something called fine-tuning. So here we are basically teaching the model new behavior by constantly correcting the outputs that it's giving us, right? So it'll give an output, you can provide feedback, and then you can adjust accordingly and basically set up the model with those parameters that are specific to you. So we just went through all of these different quadrants, right? And again, this is just a helpful framework. When you're starting to think about use cases, it becomes very easy to talk over each other. And so you can start to ask yourself, which of these are we talking about? What's the right tooling for this particular use case? And before I hand things over to Jacob, I'll leave you with a couple more thoughts on considerations that you might have when you're starting to run AI in production. First of all, there's always going to be skepticism when you're introducing a new technology into the company. And so the thing that I always recommend for people to get comfortable is find an internal use case, right? Just get people to start playing around with it. Something very common is something that's going to help your team be more productive. Maybe it's code generation tools. Maybe it's even something that helps your IT start to answer questions that they get every day about, how do I set up my laptop, right? The second thing that I would recommend you to do is come up with an AI roadmap. This is something that can be brainstormed with other product managers, with other engineers, right? Go look at your dashboards, your customers. Think about where can I optimize their experience, or where can I make our company more efficient by using AI to either get our team 90% of the way there, or by having AI kind of predict what's going to happen next. And then last but not least, set up some guidelines for internal usage. So a lot of the FUD that I've seen around using AI is with, what is it going to do when it comes to privacy, right? What do I do if someone, starts using AI at my company and leaks personalized data? And so again, that's where having some guidelines can be really, really helpful in getting everyone on the same page and getting everyone comfortable. Now, the other thing that I would consider once you're starting to expose things to your customers, once you've gotten more comfortable with it, is where do you want to run your AI on the spectrum of device, network, and centralized cloud? And there's always going to be a trade-off between these 5 things, right? So are you looking to optimize performance? Are you looking to optimize cost? Are you looking to optimize accuracy, privacy, or developer experience in helping your team go faster? So for example, in something like a self-driving car, performance is just going to be the most important thing, right? You need those decisions to be able to be made in split nanoseconds. And so that's where running the inference on the device is going to make the most sense. If you have an experience where a user is waiting on the other end of it, you still want it to be pretty fast, but maybe because you're serving so many users, it's more important for you to be cost efficient. And in those cases, it might make sense to run your inference on something like Cloudflare, right? They can provide that cost efficiency at network scale, still running close to the user. Now, in cases where maybe you want to run a 100 billion parameter model in a centralized cloud, right, then that's going to be the best thing for that use case because you want to optimize for as much accuracy as possible by having as large a model as possible. We'll be talking through some more of these trade-offs and some of the best practices in our fireside chat. So I encourage all of you to think about any questions that you might have, and we'll come back to you to be able to answer those. And with that, I will hand it over to Jacob to dive more into the LLM landscape. Oh, hop up.
Steep step. All right. Thank you very much, Rita. My name is Jacob, and I'm a founding software engineer at LangChain. And I'll be, like Rita said, walking through the LLM landscape in a bit more depth. And before I get too far in, if you're not already aware of LangChain, we're a bit newer on the block than Cloudflare or Hugging Face. We help developers build and ship context-aware reasoning applications with large language models. And while we help with various levels and stages of building with LLMs, the most relevant parts of LangChain for this talk are, our popular open source framework for orchestrating and coordinating these different modules that are important when building with LLMs, and LangSmith, our LLM tracing and observability tool, which we'll use to illustrate specific application runs a bit later in the demo. Okay, so to get some perspective on the current landscape of LLMs, let's walk through a quick timeline. In the beginning, there was the bombshell paper that introduced the transformer, the underlying architecture that underpins all these crazy recent advances in AI. Attention is all you need. We can look at this as a starting point for modern LLM development. And it's crazy to think that this is almost 7 years ago now and predates most of the AI initiatives and startups that are currently so hyped today. Well, except for Hugging Face. Shout out to Philip over there. While putting my slides together, I was actually shocked to discover that Hugging Face predates all of the hype and was in fact founded in 2016. Anyway, Transformers shocked the community by introducing this mechanism of attention and achieving all these crazy results. OpenAI was quick to capitalize on all of this training and releasing GPT-1 less than a year later in February 2018, GPT-2 a year after that in February 2019, and GPT-3, which I'm sure you're all familiar with, in 2020. Now let that sink in for a second. GPT-3 is almost 3 years old. Headlines continued at a steady but not rapid rate. And at least for me as a developer, the first inklings that I had that LLMs would be world-shaking came from GitHub Copilot and some of the attention-grabbing features they provided around code understanding. Then, of course, at the end of November 2022, OpenAI released ChatGPT and lit an inferno. We were off to the races. The Bloom LLM on Hugging Face came out around the same time, and within months, open source efforts from Meta with the original Llama and GPT for all started to emerge as the wider community began to understand the incredible potential of what they were working with. This pace has only accelerated recently with higher and higher quality open source models like Llama 2, Mistral, Falcon, and various fine-tunes with impressive benchmarks such as the very recent OpenOrca. Private frontier models continue to improve rapidly too, with Anthropic's Claude 2 recently announcing a 200,000 token context window, which is just a truly massive amount of data, and OpenAI releasing various state-of-the-art features such as assistance, function calling, and GPT-4V. And the takeaway here is that you're probably all already aware of. The landscape is still shifting extremely quickly, possibly even more quickly than a few months ago. Because of that, when building with LLMs, it's important to stay flexible and avoid locking into a specific model. The only constant within the LLM space at the moment is change. So how do we evaluate the landscape of LLMs? Well, it depends on your task, much like Rita said. But there are various benchmarks that have proven useful in kind of getting a sense of how LLMs perform in different types of data. You essentially run the LLM over a data set and have either a human or a more powerful LLM, like GPT-4, judge a result. And here's one for chat data published on Hugging Face. And it compares outputs from various LLMs, both open and closed source, and has an interesting technique where they actually they have an app where you can see the outputs from one LLM for the same prompt versus another, and a user will actually pick, and they're treated like a competition, or ELO if you're familiar with chess, where an LLM that is picked over another will gain ELO, the other one will lose ELO. And we see a few interesting open source models here, in particular Wizard LM70B, starting to approach some capabilities of some of the frontier models like Anthropic's Claude 2 and GPT 3.5 Turbo. Mistral deserves special mention as well for being an open source, very small model, 7 billion parameters. Parameters are essentially a proxy for how powerful the model is. It's how much data and how many weights are within the model at a high level. And 7 billion parameters is much smaller than most of the other models on the list, punching above its weight class, very interesting and useful. And close to the top, we see Anthropic's line of LLMs, the Claude series, which are probably of special interest to many of you in the audience here, given that you can run them privately through AWS Bedrock. So what does this all mean? We should just go off of the previous list and call it a day. And it's true that while there's definitely a lower limit, at least currently, with LLM's parameter size and kind of useful outputs here. For example, here's an output from GPT-2, the predecessor from GPT-3, that I prompted with, "How are you doing today?" And it responded with a very literal interpretation of how I am doing today by answering, "The best way to ensure that I'm doing today is to give your children an active role in the classroom in the classroom, in the classroom, in the classroom, and the classroom. And yeah, some very vaguely generically English text that you'd never want to put this in front of a user, in other words. However, depending on your task, LLMs are approaching a point where you may not need to optimize specifically for power or performance in a kind of reasoning sense to get good results for your task. For example, I asked both GPT-4 and 3.5 Turbo in this slide, why is the sky blue? And both LLMs outputted something reasonable. I mentioned things like Rayleigh scattering and a bunch of other factors. But GPT 3.5 Turbo responded almost 5 times faster. And again, still generated an answer acceptable for the task at hand here. So a few other dimensions to consider when evaluating LLMs is context, for your specific use case, our context window size, which again is the amount of data an LLM can take in its prompt, and output as well, latency, and cost. Open source models also can be a bit trickier to deploy, although folks like Rita and Cloudflare's excellent Workers AI have been making this simpler and simpler to run, as well as Hugging Face inference, and can be a bit more specific in terms of strengths and weaknesses. So, for example, a recent benchmark put Llama 2 7dB, which is a pretty large model. You couldn't run it on your MacBook. Would need some pretty specialized hardware. But they put it roughly on par with GPT 3.5 Turbo, which I'm sure many of you in the audience are familiar with, for specifically chat. However, it lagged behind on coding tasks, which can be interesting for things like extraction, where you might want to pull out specific features from some input in a structured way. So different models have different strengths and weaknesses, in short, and that's something important to think about when picking through the current landscape. All right, now let's switch gears a little bit and talk about architectures. My plan here is to walk through some handy concepts and sort of ways to conceptualize and categorize different ways of designing LLM apps so that you can apply them to your own work. At LangChain, we started thinking through various levels of autonomy. So I'm sure many of you have heard the buzzy term agents. Maybe raise your hand if you have. Okay, good chunk. And then, on the other end, you have just directly code, where you as a developer would start, writing out exactly what you want the computer to do, and the computer would then go do it, unless, of course, you have a bug. And we've been coloring the middle of kind of this mundane code aspect and fully autonomous agent with a few layers in between. We essentially think of the LLM as being able to make essentially 3 kinds of decisions. One where it just basically takes some input and outputs something that it decides. That's a simple LLM call, so why is the sky blue? It might decide to output some text on Rayleigh scattering from a physics textbook, for example. Another one is deciding which of a finite set of predetermined steps to take. So things like tool use might fall under here, or routing, which I'll get to in a moment. And at the far end, we have determining what sequence of steps is available. And this is kind of what you hear, feel the AGI from Elliot Sutskever and all the crazy things that Sam Altman's talking about. That's kind of what they're going on. And you have things like AutoGPT and things like that that are sort of steps in that direction, at least, where you basically say, here, you're an LLM, here's like a very ill-defined task, we're not gonna give you any rails, just go off and do it. So I would assume many of you in the audience are familiar with code, given that this is a developer conference, and many of you have also at least used some kind of call to an LLM at some degree, whether directly via code or indirectly with ChatGPT. So I'm gonna be focusing a little bit more in on what we call routing. And this is where you essentially let the LLM decide between one or more steps at a given juncture. It can be as simple as an if statement or a branched if statement. This can be quite simple and powerful in even a very basic form, and showcases that you don't need to give the LLM full Skynet privileges to take advantage of some degree of autonomy. Cool. Next, I'd like to dig in on another concept, retrieval augmented generation. And this is also called RAG for short. Anyone in the audience ever heard of RAG before? Awesome. So let's say you have an important research question shown on screen here. And as everyone knows, nowadays, there are 2 ways that you answer questions. One, type it into Google. We're all familiar with Google. And you would get a list of links. You'd maybe pick one. You would then go and read the link yourself and kind of get some insight into what the answer might be. And then on the other end, there's, of course, ChatGPT. where you are trusting the LLM's output directly, and it's synthesizing results from its training data. You're not like picking a source and reading it. It's essentially just pulling it out of whatever it was trained on. So if you think of these two methods as two ends of a spectrum, we can call the Google end retrieval only, where you ask Google directly again to fetch documents, and then you read them yourself. And the ChatGPT end as generation only, where you rely on the synthesized output from the data the LLM was trained on. Now, retrieval augmented generation attempts to get the best of both these worlds by combining the two ends, using sources fetched from a retrieval source to ground the LLM's generation in reality and specific knowledge. So one common pipeline for setting this up is as follows. You start with loading some data from some document. This could be a PDF, a website that you've pulled the data from, CSV file, some database. And then you split that document into smaller, semantically contained chunks. This is called text splitting. And the reason for this is you want to, when working with LLMs, you want to avoid distraction as much as possible. And by chunking inputs into semantically contained outputs, you can help the LLM focus in on specific ideas that are most relevant to your query. Next, we'll embed those chunks into a specialized database called a vector store, which Rita already explained, at a high level. And at the end of the day, it comes in many forms, but the most important part that you need to know for this is that they have powerful similarity search capabilities over natural language. So they can take some input and return data or documents that's already ingested that are most similar and relevant to your query. Finally, we will generate an output by presenting the retrieved documents from the vector store to the LLM and grounding the output. Now let's see how we can apply these concepts to build a popular chat over documents chain. And this is one of the most popular use cases of LangChain to date. The idea will be that you have some large PDF or large data source and you want to ask it questions. No one wants to read 400 pages of SEC notes. We just want to ask, where is Enron still around or something, right? So we'll start with an embedding and splitting an original data source and embedding those chunks into that data source. And then when the user asks a question, we search the vector store for the most relevant chunks and pass that to the LLM to ground it. Another key piece here is managing chat history. Since we want our, we generally want our chatbots to be conversational and take into account previous interactions and turns. For example, my first question is, who is Jacob, or who is Rita? And the vector store returns some data from some ingested chunks, perhaps a resume, perhaps like a LinkedIn page or something, and spits out something that's plausible and answers part of my question. But then I have a follow-up. I want to ask more. I want to know, do they know JavaScript, for example? So it's obvious that to a human that they represents references the last person mentioned in the conversation. But as Rita mentioned with her 50-50 first dates analogy, the LLM has no such context or no such reminders. So we also need to ground the LLM's generation in prior chat history. And the way we do that is to add another pass where we pass the initial question, the user's question plus the previous chat history into another LLM call to rephrase it into what we call a standalone question free of context. This is one example of query transformation, but sort of for a question like, do they know JS? The output would be, does Rita know JS or does Jacob know JS? And the vector store will be able to handle that much better because it will know to search for chunks related to Jacob or Rita. And the LLM will also have that context as well. And this works well enough if we want our bot to answer questions based on one topic. But if we have multiple different domains, for example, Jacob and Rita, to reduce the amount of distraction our LLM needs to deal with, we can add a step where another LLM call chooses which database to query based on the incoming question. So if the question is asking about Jacob, we only want to search for documents related to Jacob, and we ingest those in a separate store. Likewise for Rita. And this helps ensure that only focused knowledge is returned rather than potentially mixed chunks. And if you recall the previous slide on levels of autonomy, this is a simple example of routing. So how does this look in practice? And how do we build something like this in practice? Let's walk through a demo app using a very small open source chat model hosted on Cloudflare's Worker AI. And we're going to use Meta's open source Llama 2 7 billion parameters, which I could even run on my MacBook, and I've done before. And we're also going to use Cloudflare's vectorized vector stores for our database and run it on workers. So entirely kind of self-contained, one provider shop. And here it is. Let's start by asking a question. And that question will be, oh, and yes, I've already, important note here, I've prepared the vector stores with two sets of information. One, a paper by OpenAI's Lillian Wang on autonomous agents and sort of cutting edge of artificial intelligence. And the other marketing PDF on Cloudflare. So we have a Cloudflare knowledge base and a autonomous agents knowledge base. And we're going to show how the routing works there as well. So here it is. Let's start by asking a question. What are autonomous agents? So we're going to go in and ask that. And the LLM is going to go work through that architecture diagram I showed you earlier, create a vector store, and start generating. So we get, based on the provided content, autonomous agents are intelligent systems that operate independently and make decisions without human intervention, which seems pretty reasonable. It mentions things like memory, self-reflection that it pulled from the blog post and are relevant, and all in all seems like a pretty solid answer. Cool. So let's see. I think I'm having a little trouble with this in the tech demo. So let's ask it a follow-up question. Let's say we want to learn more about the memory piece of autonomous agents. So we might ask it, okay, so yeah, the follow-up question was, tell me a bit more about memory within the context of autonomous agents, but I've just phrased it as, tell me a bit more about memory. And the answer it gives is actually not quite as good. It says, great, thank you, a little bit more GPT-esque, if you will. Great, thank you for providing more context. Based on the information provided, here are some key points about autonomous agents. I think it actually seems to go back and respond with some of the kind of initial generation it made with the initial question. So I've set the app up with tracing as well, so we can go and this is where it's important to have good tooling. We can go into LangSmith and view the trace and try to figure out what happened here. So let's have a look. We'll go in and have a look at the question rephrase step. And we'll see that it took my initial question or query, tell me more about memory, and it rephrased it into something a little bit more chatty than I would have liked. And it makes sense because Llama 2 is a chat model, like a very chat-focused model, and it's very small, so it's very focused. And I get, great, thank you for asking. Autonomous agents are artificial intelligence systems that are, yeah. And this was intended to be like a standalone follow-up dereference question, and instead I got like a chat response, essentially. So that's not so great. And let's have a look at the routing step as well to see how that worked. Cool, there we go. Sorry, folks, technical difficulties. Okay, so the video didn't play, but yeah, so I've asked it basically to route between either Cloudflare or artificial intelligence based on which database it thinks would be more likely to be able to handle the question effectively. And I've also asked it to output only one of the following answers: Cloudflare, artificial intelligence, or neither. And you see again, I get a chatty, very chatty response saying, based on the question provided, I would recommend using the artificial intelligence database to answer the question, which is correct, but not in the output format I want. And the way I've set the routing actually looks specifically for the keyword artificial intelligence in the output, so this does technically work, but it doesn't seem like it's the most reliable or kind of robust way of dealing with outputs here. And there we go. Cool, so how do we fix this? And again, one of the strengths of Llama 2 is that it's tiny, open source, and very cheap to run. Again, I can run on my M2 Mac with very small GPU. But clearly it'd be nice to have a little bit more power in a few cases. If we had a user ask a follow-up question like that, they'd be very disappointed. So let's swap in Anthropic's Claude 2 hosted on Amazon Bedrock for question rephrasing and routing, the two places where it seemed to cause the most trouble, and see what happens. And as it happens, these are actually two of the more token-light tasks that than pure output generation based on retrieved documents. It just takes the question and chat history into account plus a prompt versus anything like a long list of documents and chunks retrieved from a vector database and then longer conversational output. So yeah, we have the same kind of initial question. Tell me about autonomous agents, or what are autonomous agents, and a pretty similar output from Llama 2. We're still using that for the answer generation step, remember. But let's see what happens now. So I'll ask tell me more about memory, just as before, and it'll do some thinking. And I get, based on the provided context, here are some key aspects of memory on autonomous agents. And it goes on to list a few kind of relevant ones from the blog post, which is actually pretty good here. I get things on long-term versus short-term memory. I get things on reflection. I get things on retrieval models, et cetera. So this was a lot better, right? And let's go into the trace again to see if the Bedrock chat model did much better. Hold on, let's see. All right, well, yeah, sorry about the video, folks, but we can see that it took the initial question and rephrased it to something much more kind of relevant and useful to the more simple or downstream LLM, and it took tell me more about memory and turned it into what are some key aspects of memory in autonomous agents. Much better. Now let's look at the routing step. So again, it took the initial, now this rephrased standalone question and responded with only the output I wanted, which was either Cloudflare, artificial intelligence, or neither, and responded with just artificial intelligence. So much more robust and much more easy to, reliable when routing. And the output, as I showed earlier, is what we expect. Cool, so in short, there's a lot of change going on with LLMs at the moment, and a fire hose of new models emerging, each with different strengths. Some are fast, some are cheap, some are powerful, some are easy to use, some are open source, some are private, some are good at chat, others are good at code and extraction, and some are even more customizable with fine-tuning support over your data and more exotic things like custom grammar where you can constrain outputs. And here's some links to the LangSmith traces from the demo that you can peruse. That about wraps it up for me. And a live version of the demo app I showed, and the GitHub link as well. So if you want to try it yourself and kind of experiment with different models, I know I tried, like I said, a very small, basic one on workers, but workers is coming out with some more advanced ones and more powerful ones that may perform various tasks much better. And yeah, thank you very much. We'll be on to the fireside chat now. And I'd like to call up Rita and Philip again.